This video will show you how to do these first two questions in section 6.1. It uses a program called Logically, which you can access through a web browser. And it gives you, at the very start, it gives you some options for certain logic gate configurations. We'll deal with the question, the activity question. We'll ask you to start with this 1-bit full adder and work with that. But for now, for this introduction, I am going to just click close and then describe how this program works. On the left-hand side are controls. You have input controls, things that you put into a logic gate. We'll deal primarily with the toggle switch. It's just a switch that you manually turn on and off. There are other options. One is that you can have a switch that is always on or a switch that is always off. And it's equivalent to just choosing the toggle switch and putting it in a certain configuration and not letting it ever change. So it's essentially putting a toggle switch in either up or down and then gluing it so you can't move it. And then there's also a clock, and what that does is essentially it's a toggle switch that flips on and off every certain amount of time. And then there's finally a push button. While you're holding it down, it'll be on, and when you release it, it'll be off. So these are all things that implement either a 1 or a 0 for an input to a logic gate. Then there are output controls. There's a light bulb and then a digit. The light bulb just has one input, and if the input is a 1, it turns on. If the input is a 0, nothing happens, it stays off. And the digit allows you to put in 0s and 1s on these inputs, and it will give you an output, which is a visual representation of the numbers that you're putting inside here. And the numbers that you put here are 0s and 1s, and so this thing is essentially taking a binary number and then displaying that binary number as its decimal representation. You can play with that if you'd like. And then we have logic gates. I covered a few of these gates down here. There's also a buffer and a NOT gate. The NOT gate just just takes a 0 on the input and turns it into a 1 on the output, or takes a 1 on the input and then its output is 0, so it just flips it. And these other things you don't have to deal with, the flip-flops. These are more advanced things. And then there's also a section for adding labels to your plots, to your graphs. So you just drag it over here where you want to put it, and then this is a label. Then you have a label. So let me start by doing the question that was asked in this first activity. It was to wire together gate switches and light bulbs as in the image on the top part of the page. And so here I have a certain configuration, and I'm going to implement that. So I have two switches, A and B, an AND gate, which is just the big D, and then an output, which is a light bulb. And then I've added labels, both switches off, and then A and B. Drag my AND gate over here, and we have an option of having more than 2 inputs. We're always going to do 2 in this case. And next I need a switch. So I'm going to put a toggle switch here, and I'm going to drag another one here, and then I'm going to wire them together. And I do that by just clicking these nodes and then dragging from one node to the other. I've connected this guy to this guy, and now I need a light bulb. I need an output, something to tell me what's on the output, a 0 or a 1. And here it is, and now I'm going to connect these two things. This is a label, and what did I have over here? I had both switches off, so let me type that in. Both switches off. And just for clarity, I will put some labels here. label here. I'll call this input A, and I'll take this label and call this input B. Okay, so I've implemented this first view here. Both switches off and no output. And as I mentioned earlier, these are unusual switches because when they're up, they're off. And when they're down, they're on. If you ever lived in a house where perhaps your father did the wiring, you may have experienced light switches that work in the opposite way. In this case, who's ever developed this program has decided that up should mean off. And now I can look at, I can actually copy this and click the copy. I'll put a version over here. I can't copy and paste, that's for the paid version. You can use this for free, but if you want to use all of the features, which include printing and pasting, you need to pay the extra money. But we're only going to do a limited number of problems in this class with this tool, so we'll just use the capabilities that come with the demo version. And so what I'll do next is this next case. I'll put the top switch on. So I'll just relabel this. Top switch on. And I'll turn it on. And when this thing is blue, it means that its output is 1. And then there's juice flowing through this thing. And you can see when one switch was on and the other is off, you get nothing on the output. And as we can reverse that configuration. I'll just get rid of this label. We can reverse that configuration, and as you might expect for an AND gate, a 0 and a 1 on the input don't give me an output. And then finally, an AND gate has the rule that if both inputs are 1, you get an output of 1. And so what I've done is I've essentially checked all of the possible configurations on this page. So here we have the AND logic gate table, and this configuration corresponds to the bottom row. Input A and input B are 1, and the output is 1. The next configuration is A is equal to 1 and B is equal to 0. I'll do that. And that corresponds to this second to last row. And then I've also showed you the top row where both of them were 0 and the output was 0. Okay, let me look at the next question. Figure out the XNOR logic table by connecting switches to an XNOR gate and then writing down what various configurations of the switch's input gives for the light bulb output. So I didn't tell you the logic table in the notes for an XNOR gate, but we can find one here, and we can just manually figure out how it works. So I'm going to put some switches here. And an output of a light bulb. And I'm going to wire them together. So this is some gate that I don't know how it works. Well, first thing I know is that when both inputs are 0, this gate, represented by this symbol, gives me an output. Now there are 3 more possible configurations. This being on, So now if input A is 1 and input B is 0, you get 0 output. Reverse of that, 0 output. Both on, on. So this is an exclusive NOR gate, XNOR gate. And this is the logic table it implements. Both on, output is 1, and both off, output is 1.